In this video, we will see how to draw a UML diagram that looks like this for the iterator pattern, and then set that up as a design pattern in Visual Paradigm UML, and then implement it. Okay, maybe we'll get to the implementation in the next video, but I hope to show you how to draw a UML diagram that looks like this. Okay, so we start up Visual Paradigm, and then right now I have a bunch of class diagrams in my design patterns project, so you can keep all of them in one place or keep them in separate places, that's okay. So what we want to do is create a new class diagram. Alright, and once you get that, I'm going to move all of this so that you can see as much of this class diagram editing area as possible. Okay, so we can create classes, but if you look at this, you don't want to see anything for interfaces, and the reason is it's sort of hidden. It's over here. You say interface, and it says, I believe it's got a J for Java. I'm not sure. Alright, so we're gonna call this class diagram. Oops, before I did that, I should have called it, okay, Iterator for the design pattern. Okay, so now I say interface, I click on that, and then I set up my abstract aggregator. Okay, so I call it aggregate, and I really only need one method that I have to really spell out. The others you don't have to specify right now. So I'll right click and choose operation, and I believe it's called create iterator, and I can specify the return type as I'm going to call it iterator, I think. Yes, iterator. You don't have such a thing. Oops. That's one thing I always do. I hit enter, and then it creates another default operation which you can delete. Yes, delete that. Okay, so I want to make it as small as possible because I have a lot of things. We have a lot of things in this UML diagram. Now, here's where you can use one of the many different class relationships. So what we want is generalization. Where is it? Okay, realization. That's what we want. So you click on realization. That's what you use for interfaces or abstract classes. And we will call it concrete aggregate. So remember, this is a design pattern, so later on we will actually implement or apply this design pattern to an actual application. Oops, got moved over. And I forgot to specify, you can say implements in the text box that appeared very briefly. Unfortunately, I missed my chance, but I think if you open it up, if you open up the properties, you could say something like implements or something like that, I believe. Alright, so you can specify more properties of everything. There's so many options. Now, what we want to do is make sure that we actually do return, and have a method in here. So one way to do that is to say add, or wait, sorry, go to, and I'm not even sure you can see this, so I'm going to move all of this up a little bit just so that you can see what I'm doing. you go to related elements. Oh, and then you can't see this, but I'm going to go to an option called realize all interfaces. Okay, so and what that does is give us the unimplemented methods, in this case create iterator. So for example, this, since it's an interface, you can make it abstract. Okay, and then it's italicized to mean that this is an abstract method with no method body, and then it's given a method, hopefully, in this concrete class. So this is an interface, this is a class that implements that interface, and in that implementation is an actual method with a method body and all that. Okay. So far what we've done is we've created an interface. If you were writing a C++ program, this would be an abstract class. You can make it an abstract. If you set up a class, you can make abstract classes in UML. And then after that, we created a method called create iterator and made that abstract as well. Okay, and then we made a concrete aggregate, which is an implementation of the interface, and we realized the methods, or basically added the unimplemented methods from the interface that concrete implements. Now what we want is some picture of a client class. So what happened to our classes? Well, you can get it back. And so make a client class here. I'm going to try to make it small just because I want to be able to, I want to be sure that you can see all the pop-up menu options. Okay, so now you can use association. Association is probably what you want, even though our in our slides we have a dependency. So association is a little bit stronger. It says that association means this client has, let's say, a data member that is of this type. So let's have this be an association. Dependency is usually considered to be weaker. A dependency means a temporary variable or a method parameter, things like that. And that's what we had in our class diagram from the notes. So these are dependencies. What I did was I said, well, just for a variety, I made something stronger that is an association. You can use either one. It's not a huge difference. Okay, so now that we have this much, now we want to set up the actual iterator interface. Let's just make it an interface. Remember, interfaces are just hidden temporarily. So here we have our iterator, and kinds of methods we want in there are, oops, I just realized you can't see this, but alright, let's see. There, that's a little better. Can't see all of it, but enough. I'm going to create an operation called, let's say, next is the most crucial one. And then this will return. This will return an element. Okay, so, and let's just not maybe specify it. That's okay. So it's got a public method that's next, and we're not actually specifying what kinds of things. I just realized that it's not a huge problem because it's just a diagram after all. Alright, so I'm going to make this abstract. Of course, I think by default interfaces have all methods abstract, and UML doesn't do this automatically for you. Alright, so after that is maybe something like is done. And what else do we need? I forgot. Next is done, and then current item. Add a method. Oops. Before that, we want to make this abstract, and then add. Oops, you can't see it. I keep forgetting what you only see part of my screen. We wanted, oh, totally lost it. Current item, something like that. Is that right? Yeah. Okay. And let's make it. Sorry, I keep moving my pop-up menu. It's just I'm trying to remember that you can't see all of my screen. Okay. So let's say that iterator is more likely to be just a temporary variable compared to an aggregate object. So usually a client will have a data member that is an aggregate, like a list, a linked list actually. And probably iterators are going to be temporary variables, so we're going to use a weaker form of association called dependency, which is somewhere. There it is. So I just click on there, and I bring it over to here, and I see the arrow, the dashed line with the arrow, which we saw in our class diagram. So I just happen to choose dependency for iterator and association for aggregate because I'm thinking this is more likely to be something like a data member, whereas this is more likely to be something like a temporary variable. Alright, so it's slightly different from the nodes. And then finally one more class, which is the concrete iterator. Oops, I just realized I don't want to do that because I want to show you. Well, this is fine. Let's call it concrete iterator. Okay, and then we can use. We have to draw the inheritance from the superclass to the subclass, I believe. Yeah, I'll find out. Let's see, where is it? Containment, generalization, and realization. So there it is. Okay. For interfaces, it is realization. For if you draw a generalization from an interface to something else, that is like a super interface. Makes this a super interface. This is just regular implementation. Okay, and what can we do in here? We can say I just realized you can't see this. So I'm going to move it temporarily way up here. And related elements. Oh, hope you can see this. It's realize all interfaces. Okay, now that you can see it, I can move it to where it should be, like about here. Alright, and then it has those abstract methods with hopefully method bodies. Well, you know, this is all just diagramming, and we can generate code from it, but right now it's just a diagram. I haven't even told you return types. Okay, let's do that right now actually. Open specification, return type should be Boolean. Okay, and it says operations with the same signature as old is done. Boolean exist in the following classes. Do you want to synchronize the changes? Yes. So what I did was I changed the return type up here, and then it changed over here. So you can, if you're not sure exactly what this is going to return, you can decide on things like that later, and it'll sort of fix things up for you. That's a little better. So now I want to create the last thing, which is